Many of you have been working on coral reef restoration for just a few years. Some of us have been working on reef restoration for 10, 15 years. There's probably only a handful of people in this room that have been thinking about reef restoration for the last 25 years. And this man is one of those people. And so he's going to tell us a little bit about where we got our start and where he thinks we need to go as a field. Buki, thank you.
Do you hear me? Okay. Thank you, Tom, for the introduction, and I would like to thank the organizer for inviting me to give this talk. Today I'm going to present here an overview of the activities that we have started 25 years ago, the notion of gardening the coral reefs. I'll talk about a little bit about the problem, about the activities, and how it was developed till the situation that we sit here and talk about reef restoration. So there is no need to convince you that, reefs all over the world are declining. Just some examples from places that I visited there. And also, if you look on the belt of the coral reefs and you see the countries there, more than 70% of the population in these countries live nearby the coral reefs, less than 100 kilometers. And there are hundreds of millions of people all over the world that depend directly on coral reef resources. So I believe that all of us will agree to this very short statement. First is that coral reefs suffer worldwide decline, the results of human activities and the result of global change impacts. Effort to conserve coral reefs with activities like marine protected areas have failed in most of the cases, and this decline has raised the needs for additional efforts, additional tools to conserve these reefs. And I would like to have only one slide to emphasize what is active reef restoration. You can see on the left panel here a bunch of people replanting Gorgonian corals after the tsunami in Thailand in 2004, putting back boulders of Porites. They are very active, but this is not active reef restoration. Active restoration is on the right panel. You see silviculture. You see this silviculture, the trees that are on line, thinning the forest. Active restoration is an act that you do ahead of time, and you think 30, 40, and sometimes 100 years ahead of time. So it is not like taking corals and planting them, but doing that with a real thought and a real plan. So 25 years ago, almost 24 now, we published after reading the literature, we published the first paper dealing with the gardening concept, and it sounds very simple. In one end, you should raise corals in nurseries. By the way, the term nursery was not there 25 years ago. So we take corals and put them in nurseries, grow them in nurseries, farm them in nurseries, and then transfer, in the second phase, transfer these corals to the degraded reefs. So on the basis, it sounds very simple. And I had a student, a PhD student, that asked me to have the first nursery in Eilat, to build the first nursery in Eilat. Of course, I was very happy about that. And the outcome was that this was the only chapter in his PhD thesis that was never and will be never published, because we did the regular nursery attached to the bottom, and the corals did well. Some of them died, some of them survived, they grew. So it was okay, but no more than okay. And I was really frustrated from the outcome of these results. And then one day I was invited to dive in nearby the fish cages that we had, fish farm that we had in the North Gulf of Eilat. And going back from the dive, I was overviewing these construction, the ropes and the different attachment processes that they had to the bottom. And then I saw these and other huge, large colonies growing on these ropes. So when we went back, I asked the manager when they put the ropes, and he told me, and for me it was a little bit strange because generally speaking, I know the growth rates of these corals in the Gulf. It was too much, too fast. So I went back to the lab and I contacted one of my postdocs, Lucia Bongiorni from Italy, and we constructed a very short and a very nice, simple experiment. We put nearby the fish cages a construction, because the fish cages were floating in the water between 0 and 9 meter depth, above 30 meter depth of the substrate was 30 meter below. So we put a very small construction nearby the fish cages and another one in a reference site about 10 kilometers south. And the idea was to have a short experiment for 1 year, but it was terminated after 7 months. And the reason was that it's not because the coral died, because we had 100% survivorship in both sides. It was the result of the fast growth rate near the fish farm. And you can see the outcome. These are the skeletons. This is coral number 9, and same branches other branches of the same genotypes, number 9, number 10, number 10. You can see the difference between these two sites. These results brought us to 2 turning points. I call them innovations, 1 and 2. The first, mid-water floating nursery. And I would like to claim that in most of the cases, mid-water coral nurseries are superior to attached to the bottom nurseries. The second point is put the corals near nutrient-enriched area. Not polluted area, but nutrient-enriched, because fed corals are happy corals. And then we had some problems with our authorities because they didn't allow us to take many branches for the nursery. So we had to think how to overcome this limitation. And then for the first time, we went down for very small pieces of coral fragments. We call them nubbins. And as a matter of fact, in Stylophora, Acropora, and Poecilopora, we went down to a single polyp. And you take this very small fragment, attach them to plastic pins with a little bit of super glue, and you can take them also from corals of opportunity, and they grow. Almost 100% of them grow, and they do very well. So the idea of having nubbins also reduces the impact on donor colonies. So this allowed us to go from very few. My first permit was on 36 corals, branches. 36 branches, you cannot do restoration. It's a failure from the beginning. But if from 36 you do 1,000, then you can do something. So the first nursery contained 5,000, this is the first one, 5,000 coral fragments, and they grow very well. When I say they grow very well, you can see this coral, this Acropora, starting from the day 0, 3 months old, and 400 days, 1 year and 1 month. You can see a very short period of time, you go to a nice, healthy coral colonies. And not only in this species, just look on the growth rate of these Poecilopora colonies and these Poecilopora colonies here and there. the difference are only 2 months of growth, and you can easily see how they grow. You can also easily see after 2 years, we came up from very, very small fragments, nubbins, to this size of really healthy coral colonies. And then, following the rationale of forestation, we changed this rationale because nurseries on land are sterile. They use a lot of insecticides, pesticides, and other materials to keep the trees intact or without any other organisms. On the contrary, the nursery in the field, a coral nursery, is open to the ocean, open to the environment, and there is recruitment of so many organisms. There are hundreds and thousands of species and organisms and individuals that come and attract and settle from the plankton. And we come to a point where it was pity to destroy this new environment, the Noah Ark that was developed, a floating reef that was developed, because you destroy environment that you created just to transfer these coral colonies to other places. And then we came to the idea that a nursery is not just a nursery, because nursery can be built in accordance with the needs and what you want to do in the future or after having the colonies in your nursery. So I'll show you 6 or 7 types of nursery, and there are many other types. The first is the frame nursery, where you can work in both sides, very efficient, very easy to work. The mini depth adjustable nursery, where you can do small experiments, very easy to adjust them. A pipe nursery, where we hold large colonies that you cannot find in the reef. You can grow them again and show that these colonies, the potential of their growth, which is limited when you put them in the reef. Or the bed nursery, where you have so many corals, put them, and just 100% of the nursery is covered by corals. Or vertical rope nursery, where we hold stock colonies to be used later on for other purposes. And one of the real inventions of one of my students, Gidi Levy, that insisted to do a horizontal rope nursery. You just open the twist of the rope and immediately hold the branch or the fragment. Of course, here you need to take larger fragments. And within a very short period of time, they just cover the whole length of this nursery. And when you transplant the nursery together with the corals that are growing there, or the depth adjustable nursery that was developed in one of the people here is also, you can see him here, younger, of course. And there were a lot of Coca-Cola empty bottles in the frame just to hold the nursery. This nursery stood 2 hurricanes. So you reduce it before the hurricanes and bring it back without harming the corals. And it happened that, and this was something that we didn't think about that before, that corals in the nursery enter into sexual reproduction. For Stylophora pistillata, which is our model system, model species, it took 2 years from a very small nubbin to a coral that is sexually reproduced. And these larvae are much, much, much better than larvae of natal colonies. And don't forget that we take from natal colonies that are the survivors of all past events. And just to show you under laboratory experiments, after almost 3 months, the sizes of the natal larvae taken from natal colonies as compared to larvae from the nursery. And then there are 2 ideas with it. We didn't test this idea. And I would be very happy if one or more of the people here will do that. One is seeding the reefs. We can, during reproductive season, you can tow the nursery upstream to a reef that you want to seed with larvae, and naturally larvae will go into the reef, and we estimated that 10 by 10 nursery with Stylophora pistillata corals can produce during the reproductive season more than 20 million larvae. You can imagine the impact of 20 million larvae added to the reef. And the second approach, which is very interesting, is to make stepping stones of nurseries where you can connect between two different reefs that are not connected through these floating nurseries that are in the water. And then we realized that, again, against the rationale of nurseries on land, we don't need, if we build the nursery as we should do that, we don't need to invest a lot of manpower in maintenance, because many grazer fish and vertebrates are attracted, settled there, and they do part or most of work that we should do that. So, something is wrong. I know what I wanted to say here, so I'll do that without the legend. The nursery is so proliferative at the floating nursery, because this nursery swings in the water, and there is a flash of, first of all, sediment is reduced, there is flash of freshwater, oxygen, and plankton, and there is attraction of many larvae coming from the plankton. And as a matter of fact, up to date, we made, in the nursery, we farmed around 90 species all over the world, and in more than 20 sites, I think around 20 sites in the world. And just to summarize, a nursery should be in protected area, away from divers, away from storm. In an enriched area, we should use nubbins. We can do mid-water nursery, which is, as I said, a preferable way, and multi-deck nursery, where you can farm colonies to the right depth that you want to transfer them. And the maintenance is with the help of grazers. It can be a hub for sexual reproduction, and of course attracting many other organisms. Okay, so the next step is to take these corals and transplant them. And as you have for each seedling or tree, you have a pot. Here you can make pots also for these corals and transfer them in a similar way that you transfer trees in the reef. It transfers trees on land. But then we have to stop and think, what do we want? Because it is not just taking corals and putting them back to the reef. And I'll give you an example of these three, a small site in the Reef of Eilat that was visited 69, 73, and 2001. And you can see here 8 of species, the most common species that were there. And for example, for Stylophora pistillata, we had 164 before, and in 2001, 48. The same for Millepora dichotoma, which is fire coral. You can see the differences. Now we need to think, do we want this reef to contain 200 corals, Stylophora, 110? We have to think. This is one of the most important parts, according to my belief, in the restoration. It's a very important step in understanding reef restoration. And then also we should decide, do we want to transplant them in aggregates or each one differently? If we have several different species and several different genotypes per species, how do we organize them in the field, in the space? And the most important thing, view your transplantation technique. And I'll show you one of the, we had a lot of failures. One of the most successful failures, it is in Koh Pai Island in Thailand. That is a pristine area that was destroyed by the tsunami. And we were told that this side of the island is protected from the monsoons. So we transplanted there before the monsoon several thousand corals. And after the monsoon season, we came there to see the mortality, the growth rate, the survivorship, and so on. And we couldn't find neither one of our colonies. So from that, we came to this innovation, new transplantation methodologies. And I'm going to show you several methodologies. There are more, but I'm limited with time. You can see here how one of the options to transplant encrusting species together with their substrate. And you have to think about that substrate before. Or this is very, very, very easy. If you want to transplant corals on gravel or sand, you just take this iron mesh. You can find anywhere. You can find them anywhere in the world. They are used for concrete plates, and you just cut and bend, as you can see here, the frame. You come with your corals, with the plan, and immediately you can attach with plastic. Yes, plastic ties. Thank you very much. Immediately, and it is very fast. If you have a good plan, it takes half an hour you can do, and more than you think you can do. And this is the result. After 1 year, you don't see the mesh anymore. And you see this fish. This is from Bolinao, I think, from the Philippines. Yeah. You see how easy it is to make this reef when you have a real plan. Or for the rope nursery, we just use these wooden boats with the 2 extensions from both sides. And then what you do, you tie the rope underneath to the other side and go very slowly. And a team of 5 people can transplant here 5,000 colonies in a single day. And we put them side by side, the ropes 25 centimeters from each other. It took 1 year, 10 months. And you can see the whole area is covered with Montipoa digitata colonies. And the rope nursery on hard substrate. Here you can see how we attach them with nails on the substrate. And these Acropora colonies, if you don't see the nails here, but one of them is here, coming out. So these colonies were not there, the fish were not there. It clear cut that this is a very efficient way, very fast. And this is very interesting point. Most of it is not published yet. We are now working on the results. I asked to make a transplantation act in Eilat, and I was 5,000 corals. I was firstly denied, and then they allowed us to transplant only less than 1,500 in 3 sessions. 1.5 years between the 3 sessions. And they say because they're afraid that I'm going to destroy the natural reef. And they gave us a very bad area, really very bad area for transplantation. You see one of the knolls there, completely denuded. It's called the Dekel Beach, which is Pan Beach in Hebrew, in English, but Pan Beach from Hebrew. And this area is in front of a diving shop, and there is pollution in the water. And I said to myself, should I do that? Because if I fail, then people will say the whole story is failed. But we decided to do that. Yes, we were asked to take these colonies 3 years after that out of the water. This was 2005. And then we transplanted the corals there by drilling holes in the substrate. It takes about 1 minute to drill a hole, and inserting the corals with the pins, and so also with a very little amount of glue, epoxy glue. And I would like to give you only 2 dramatic, I think, results coming out of this experiment. What you can see here, the red line, is 38, okay, some of the anoles were transplanted only once, some of them twice. I think one was transplanted 3 times. Now, what we followed here up to 38 months, more than 3 years after transplantation. And you can see the first transplantation, around 40% of the colonies survive from the first set of transplantation were survived. The second transplantation event, the same site, similar colonies, after 38 months, additional 38 months, 90% of survivorship. It's reminiscence, the activities that people do on land when they prepare. You have to prepare the substrate, the soil first, with nutrients, with moisture, with carbon, for the transplantation of trees. So if you failed with the first round, don't worry, the second round will be highly successful. And the second very interesting result is the reproduction. You can see here the 3 sets, 1, 2, 3, and the local colonies. And don't forget, the local colonies are the most successful colonies in this area. And the reproductive activities of the transplants was in an order of magnitude more intensive than natal colonies, not 1 year, not 2 years, up to 8, that's what we checked, up to 8 years after transplantation, 8 reproductive seasons. And we believe that something happened during pampering the colonies in the nursery, and we suggest the epigenetic impact, and we started working on that as well. So this is the reef. This is the reef as it was, the knoll as it was before. This is what it is now. It was taken 2017, but the same. There is no difference till now. And I'll show you a very short movie on this reef. But another idea. If you are at home and you have a new house and you want to have a garden, you call the company to have the grass lawn around your house. It takes about a few days, and you have a very nice green surrounding of your house. Why not doing that in the field? Here you see sandy area. Of course, nothing is there, and you bring the units, and we did 3 of them. We call them coral units. Each one is 3 by 3 meters, and you can see 6 months after, one year after, in one of the most not suitable sites with a lot of sedimentation, and there is recruitment of corals. And just think, not 3 by 3 meters, think about 300 by 300 meters and the impact on the environment. And the last, I think, innovation is what I call ecological engineering tools. One of them, and I don't have time now to go into the details, is to how to cope with global change impacts. The second is what we do, coral chimeras, a fusion of corals of different genotypes to form a new entity that can stand better environmental changes. And what I call tiling the reef. You can tile if you have a reef that is covered by tough algae, or you have artificial walls that you want to cover. The first experiment was performed on clear CDs, and you can see the nubbins here. In 7 to 9 months, you cover completely, and then the surfaces, and then you can attach them to any substrate that you want, and you change the environment because you don't care about these animals, about the alive corals, because even they die, and we want them to die, sorry, you provide a new substrate for larvae of corals. Now we do another experiment using not CDs, but tiles made of coral sand. And one of the questions is how to bring this reef to as close to primeval characters. For sure, we cannot do that. We cannot reach this state, but I'll show you now this a short movie, just 1 or 2 minutes. I'll cut it in the middle. Can we have it? Then to show you the reef. First of all, how we drill it, the holes. The power is from pressed air from diving tanks, and we made about 20-25 centimeters from each between the different colonies. Of course, it was pre-planned, but you can see the environment is a little bit different. And I'll show it now. It's just showing you the procedure how to drill. And as I said, it's take about a minute. And this was the reef that was transplanted. You can see burned reef, and many of the colonies were even smaller. Each of the colony was, according to the permit, was labeled, and we put them one near the other on a really burn nubbin reef. And just see this reef now. The picture was here is the reef. This was taken in May 2016. It is like that today. This reef was transplanted twice, and this is one of the successful stories. Reefs that were transplanted only once failed. They are now without corals. And I'll show you just before I leave this movie, just a close-up. You can see the recruitment of other smaller colonies, the number of fish and other invertebrates you cannot see, but believe me, full loaded with different invertebrates. Can we go back to the slides? Yeah. So during this period, we faced 4 major challenges. The first was to show that we can raise coral colonies from different species in the nursery. It was highly successful, not only by us, by so many other people. Secondly, is to convince that we can have stocks of coral colonies, and we can now raise hundreds of thousands of coral colonies. And the third one is that to show that corals do well in the new transplanted area. And the fourth, I didn't have time to talk about it, is the cost. I know it's important. And for the rock nursery, it's about 17 cents to grow the coral in the nursery and 19 cents to transplant. So less than $50, you have a coral in his new home. And now we are facing 2 major challenges. The first, which I think is a community effort, it's not a single scientist or single person effort, is to transplant 1 million corals in a single site. And believe me, if we are successful to do that, the outcome will change completely. The whole overview of other people and also the belief of authorities in reef restoration. And the second point is to have the ecological engineering approaches, as Donald Rumsfeld said, to find that unknown that we don't know that we don't know. So thank you very much for your attention.
Good morning. I'm Heidi Stiller with NOAA, and I'm here to moderate questions during our plenaries. And the key word there is questions. I know we all have scintillating comments, and I hope you will share those with each other during our breaks and at lunch. But we have about 10 minutes now for questions for Dr. Rinkovic. We have 2 speakers or microphones in the aisles here, so if you have a question, please come up to those microphones, and we'll take about 10 minutes of questions. Yes, sir.
Thank you very much. That was a real inspiration. It's a pleasure to hear from you. I'm quite interested to see that you were starting the microfragmenting process, but with in-situ nurseries rather than ex-situ nurseries by the looks of things, and what kind of frames it looked like they were suspended on ropes, those little tiles that we were doing, and maybe you could explain the kind of framework that you used to set that up, please.
For your first question, we do the attaching the nubbins in the lab, and immediately you put them back in the field. The best way is to put them in the nursery. Nursery should be in a very protected area and quiet area with flash of water, and they do well. If you do that in the right way, there is no problem. With regard to the second question, you just take a rope and you open the twist, and then you need to have, according to your species, enough material that can be inserted and also be outside from both sides, and that is. And you make a plan. I want colony genotype A of colony of species number 1, genotype B, species 2, and so on. It is your, depends on your needs and your ideas, and then you put them in a nursery, and don't be too environmentally friendly, because we tried to do that first with bamboo, and the first storm, everything was destroyed. So we are now doing that with plastic frames to hold the corals.
Thank you.
All right, very good. Yes, ma'am.
That was really fascinating. Thanks for that overview. I'm really interested in the idea of ecological succession being important for restoration, and I'm just curious if it's like any coral species is good as long as you're doing it multiple times, or if there's like certain species that being like the initials and then a second round and then a third round.
If I'll follow, I know that this was the only experiment that has been performed, so I cannot tell you from my experience more, but I can tell you that in the forestry, they have several methodologies how to prepare the ground for the real transplantation event. And we should think about it. We should think about it because there are tough algae, and from really preliminary result, we saw that when you put large colonies in an area with tough algae, with time they disappear, tough algae disappear. And then if you don't have too much sedimentation in the area, then everything is covered with sediment. But if there are tough algae with not so much sedimentation, then something is happening there, probably the impact of the corals, and then coral recruits, larvae can settle there.
Thanks. Yes, sir.
Hello, sir. My name is Colin Howe, and here in the Florida Keys, we don't have a lot of species diversity as they do overseas in the Indo-Pacific. And my question is in regards to the hybrid corals. I think you referred to them as Crimeas, but from your experience, what was your work with hybrid organisms, corals in particular, and what their role might be within coral restoration methodologies in the near future?
Okay, these are you point out to very interesting sets of experiments that are performed by different people, and we decided to concentrate on coral chimeras because most people are not familiar with that many of the corals in the field are chimeras. There is a window in ontogeny when larvae settle, and I know for few species that I worked on, but there is, for example, for Stylophora piscillata, up to 3 months, for Seriatopora in Japan, up to 2 years. The small spot, when they come into direct contact, they fuse and they form chimeras. And we know about chimerism not only from corals. I worked on chimerism on tunicates, and there are people working on human chimeras. By the way, all the people here that look on me are chimeras. And there is a lot of evolutionary and biological, ecological aspects to chimerism. I can talk with you later on, because when I start with that, I can continue for hours.
I understand that.
So I'll stop here just by saying that, yes, this is part of what I said, ecological engineering approaches that are not just raising corals. We now are confident with the different tools that we have in our toolbox to put more attention to these types of ideas.
Thank you.
All right, thanks. We have time for one more, maybe two. Yes, ma'am.
It's more than a comment than a question, because for us in the Caribbean, we have seen that the failures are related to water quality, that there's pollution close to the restoration sites. And also, I am happy about your successful story at the end, because as here there are hurricanes, so that's more stable. That's an option that could be to have different species in the same structure on the substrate first. So for me, it was because I was very skeptical about all these structures, artificial structures. So with the rocks, I think it will be more successful also here in the Caribbean. And the last thing is that I have the tag number 57.
She's clever. Yes.
Just one, Bucky, Sarah from Seychelles Project. Your midwater nurseries became floating ecosystems. And so was there a moment where you guys just decided we stop cleaning and
Yes.
let it grow?
Yes.
Or when
Yes.
was that one moment?
There is a turning point where you don't need to touch your nursery. Yes, you need to touch it because of the weight. So you have to add more buoyancy to the nursery, because more and more corals are there, and they grow, so the weight puts the nursery down. So I had the discussions with engineers, and now we have not we personally, but in general, we have the capacity to have floating nurseries, 3D floating nurseries. And I'm just thinking about tourist attractions that can be associated with raising corals in the nursery. So this is a win-win situation where you raise corals. Of course, the question later on is, should I take the corals from the nursery or not? But if you have a plan, you should do that and replace the corals in the nursery.
All right, we have to stop. Those of you with additional questions, please save them for breaks or lunch. Please join me in thanking Dr. Rintelmann.
Thank you very much.